Hello everyone, I hope everyone is doing good and welcome to the channel. So in this video we are going to talk about RAG and MCP. What's the difference between both these two things, and what are the use case where RAG can be useful or the other use case where MCP can be useful. So currently in the industry there is a lot of confusion between the use cases of RAG and MCP, but a modern architecture or modern GenAI pipeline architecture is something very different. It's a combination of RAG and MCP. We are going to look into the very easy explanation of RAG and easy explanation for MCP. We are also going to see the combination of RAG and MCP, and also we are going to identify that where LLM comes into the picture for this full pipeline. If you are new to the channel, please subscribe to the channel and do share this channel to your colleague, to your friend who want to transition their career to data engineering field or who want to grow into data engineering field plus GenAI pipe. So in RAG, retrieval augmented generation. So in RAG, generally it's a step-by-step process, and there is a concept of vector embedding. So before developing the RAG application, you should understand what is vector embedding. So I already have created a video on vector embedding with the help of ChromaDB. You can search in the GenAI playlist. But in a simple language, there is a long documents, and you are chunking the documents and create the numerical assignment or a vector to each chunking. So that is vector embedding. So you create the embedding, you assign the number to that, so and create a multi-dimensional vector in any of the vector database like ChromaDB. So you already have a vector search. For example, you have a large document, company policy. So you create embedding of, there's a process for that. So you create an embedding for documentation. That embedding is stored into some vector DB. So now I assume that we already have the vector DB in the system. Okay. So you ask the question, that question goes to the vector search. Means a searching is done on the vector DB on the multi-dimensional information vector. Once you get the information, so that information plus context, like what is the context of that question, both is passed to the LLM. So once we get all this information into the LLM, so LLM is here responsible for generating the human readable answer with the help of context and the answer which we have got from the vector search. In vector search, generally we do the semantic search. A near about answer is being generated, and now this information is given as an output. So you can see in the RAG we are generally retrieving some information. So there is no special agent involved into it. No special decision making is involved into this process. There is a vector DB. There is a information in the database in the form of vector. With the RAG, you hit with the question to the DB. You get the semantic answer, near about answer, and that answer with the context is given to LLM, and LLM can refine that answer and make it more in a presentable format. So now if you have a scenario in which you have to make the decision, like where to search, if you have to draw any diagram, if you have to call any action, like you want that user want that go and check the status of that running job, so that cannot be done with the RAG. Plus, if you want a data which is live, like for example, which is in the recent format. So for example, you want to check the what is the stock price of particular share. So that RAG cannot do, because RAG searching is done on the vector embedding. So how new or how fresh is your vector embedding, that will decide the relevance of your answer. For example, today is the match of in India and New Zealand, and the vector search or the database contains the match information for 1 year back. So you have done the vector embedding 1 year back, and you ask about the India and New Zealand match information. So then that answer will be irrelevant. You will get the wrong answer in the RAG architecture. So the biggest disadvantage is it only works on the text. Means it works on something which you have stored in the vector form in the vector database. Second, the answer relevance is depend on how new or how what was the last time when your vector database was refreshed. This is the second point. Third point is it cannot perform any action. So this is the biggest disadvantage of RAG. You can only retrieve the information, but you cannot perform an action. So there the agent has come into the picture, like to perform an action. So that we'll see like how MCP solve that particular scenarios. So now we saw that there are multiple disadvantages in this architecture. The biggest thing is it cannot interact with the other system. For example, I want to fetch the data from the Snowflake system, then your RAG application or the RAG architecture AI application cannot search in a Snowflake. So we need something which can interact with the other tool, which can interact with the external environment. And for that, what we do, we create an agent. Like you ask the question, LLM decide work on the. We create an agent on that LLM. That agent decide, or the information which is passed to the agent. That agent takes an action, connect to some application. For example, I have a database, and from that database I want to fetch some data. So agent will go into the database, fetch the data and get it back to the LLM, and you will get the answer back. So for example, in your AI application, you need to connect to multiple database. Plus connecting to the database, you also need to get information from the Google or from the internet. So in that case, you have to make multiple AI connectivity. You have to write the code to connect the agent to the particular database. For example, Snowflake. You have to write the code to connect the agent to the internet from the Google to get the answers. So in this kind of scenario, for each AI application, you are writing multiple connectivity to the external devices or external tools. So it will be very difficult to manage these all kind of connection. So what MCP has brought one solution. Like, it creates a server. In that server, there's a list of tools. For example, I need to connect to Snowflake. I need to connect to Oracle. So how to query that? So that's SQL query, or what all tools are required to query that these two particular database. All that information is passed into that tool. So you don't need to write a connectivity to each of the external tool. You just need to connect to the MCP server, and that MCP server will help you to connect to the external devices. We'll see how it works. So now we understood what is RAG in a simple term and what is the disadvantage of RAG. Now we'll see MCP, what is MCP and how it solves this problem. So now we'll see what is MCP. We'll try to understand in a very easy language, and we'll see that how MCP solve this problem. Like, the RAG problem is already solved by connecting to the different devices with the help of agent. But how MCP overall solve this, give the structure to the solution of the problem which was there existing in the RAG. So MCP stands for Model Context Protocol. So actually it gives the context to the model. So we'll not go to the definition wise. We'll understand what it is in easy language. So it standardizes how AI model connect to external tools and data source. So how your AI model connects to external source. Like, so if you just want to connect to any database and retrieve the information with the help of your AI application, you don't need an MCP. You can directly write an connector. So similarly, if you have to connect to multiple external sources, you can directly write the connector. You can directly write the API to connect to that tool and get the information, or you want any action to be performed. But that is a problem. For example, you in your system, you have a one AI application, 1 2 3, and for each application want to connect to a database. So you have to write a custom API for each application to these database. So instead of that, what MCP does, MCP creates a server in which all the tools are there in the server. For example, run SQL query tool, read a file is one of the tool, call API is another tool. So that tool information is passed to this MCP server. So what will happen? Your multiple AI application can use a single MCP server which has a similar kind of tool. So instead of writing all this information, these many custom API, which is very difficult to maintain in the future, you just need to maintain one MCP server. And if you in the future, if you want to add more tools to the MCP server, you can add the more tools to the MCP server and restart the MCP server, so that your application will be in a good maintainable mode, and not much of the problem will occur when, if any of the database connectivity fails or changes. Now, take another example. You have to connect to Yahoo server to get the stock prices. You have to connect to some money control to get the stock prices. You want to connect to the Google to get the stock prices. So you created a different custom API for that, to connect to that. Now, for example, Yahoo has like the information it exposes in the format, it changes the format of information. So in that case, you have to change that custom API which you have built to connect to the Yahoo server. But in MCP, that is not the case. For example, Yahoo has created its own MCP in which you can directly connect to that and get the information. So you just need to change the MCP tool if it required, but you don't need to change any logic to connect to the particular server. So this is the biggest advantage of MCP. So it standardizes everything when you connect to the AI model. So we started with a AI LLM. Then we created a architecture in which there is a document, company policy, anything, documents. The documents is created a vector embedding out of the document. We read the document, get the similar answer, give to the LLM. LLM gives the more customizable answer. Now we need something which can take an action. So we just don't want the your AI application to give you the flight information. We also want AI application to connect to the flight provider and try to give the information like how to get into that flight, means how to get the tickets and the booking of that flight. So now you want the AI application to to perform an action. So in that case, we have come up with an agent, and that agent connects to your other application. Now the current scenario is we have MCP, which standardizes how we connect to all these external sources. So this is the biggest advantage of MCP, and it solves the problem which was there in the RAG. Now with the help of MCP, we can say that we can do multiple things except apart from the retrieval of documents, which was only present in the RAG. Like we have the RAG only for retrieval of document. But in the later part of videos, we will see that how RAG is also very relevant in the today's GenAI pipeline architecture. So now, as discussed, like how MCP works. So there is a small snippet for that. So how it works. So there is an MCP server in which tools are exposed. So step one is the tools are exposed via MCP server. The MCP server exposes tools like run query tools, read file, call API, get sales data. In fact, there are companies. Snowflake has their own MCP server. Different companies, product companies, has come up with their own server. You can also create your own server, and then you can create the run SQL query on that. You can have the tool in that. I'll just in a different video. I'll just show you how to create the own MCP server. It's not so difficult. Step two is your AI application or your AI client discovers the tool. So what will be your AI client? For example, the cloud or the cloud, desktop cloud, or your VS Code. In fact, in PyCharm also there is a MCP connector. So once you create a MCP server, there is a process for that. You can give that server name, the configuration in these AI client. For example, VS Code or cloud desktop, and then your AI application will be intelligent. I'll just show you where that intelligence comes to choose the tool. So your AI application will connect to this MCP server which you have configured, and it sees the available tool. So the tool is, for example, execute SQL, fetch customer data, read document, and that AI application will be intelligent enough to understand that which tool it has to use from the MCP tool. So AI chooses this tool. So user has asked what were yesterday's sales. So AI decide which tools to choose. So AI decide like execute SQL, and MCP execute the tool. So MCP runs the operation in which it creates the query, and it gives you the output like what was the yesterday's sales. AI generate the final answer. The AI convert the result into natural language, and it gives you the answer. Now, here important thing is there are list of tools, and your AI application will use the intelligence to decide that the user question need which kind of tool. So, you can see here, there are three tools available in the MCP server, but your AI application uses only execute SQL. It doesn't uses read document or fetch customer data. So, where that intelligence come, we'll see. So this is a general way how MCP works, and that intelligence will come from the LLM side, and how the LLM is useful in this MCP context, MCP architecture flow. We'll see it now. Now, as I mentioned, the intelligence to choose the tool. So there's a big role of LLM in this MCP architecture flow. So we'll understand what is the role of LLM in this whole picture. So like in RAG, the LLM is used to get the only the context and answer. LLM comes into the picture after we retrieve the data. So retrieve the semantic information from the vector embedding. That vector embedding answer plus context is given to the LLM, and LLM creates the answer, human readable natural language answer to the user. So that was the role of LLM in the RAG. So we'll see that what is the role of LLM in the MCP. So when the user gives the request, for example, I have the request, what were yesterday's sales? So LLM first interprets the user natural language. So LLM understand what's the meaning of this line. So LLM understand its what is the intent. The intent is to get the sales data. So and the data source likely database or analytical system. So LLM determines that what from like this is this information can be retrieved from the external data. Now, it decide which tool to use. Like in MCP server, there are multiple tools as I mentioned. So this LLM now understand that what was the intent. The intent was to get the data from the database, external database. So it decide which tools to use from the list of tools which was present in the MCP server. For example, exit SQL, fetch customer data, read file, call API. From here, the LLM will decide on or understand which tool it has to use. So then LLM evaluates the tool and choose the correct one. This is very important. See, MCP solves the problem to have the tools in one server and give a single connectivity to the multiple external devices. But where the intelligence will come to choose the tool from the MCP server. So LLM has that intelligence. It gets the intelligence from the user's intent. So it is also very important. Like when you create your own MCP server, you have to combine a similar kind of work in a same MCP server. You cannot have many tools which are of different category in a single MCP server. Then it will confuse the LLM to choose which tool it has to use for the user prompt. I hope you understand till now. The LLM evaluates the tool and choose the correct one. So example reasoning user question need database data. Best tool is execute SQL. Now generate the tool call. The LLM then construct the tool request in a structured format. For example, execute SQL input, select some cells from order where data is equal to yesterday. LLM creates this input parameter to the tool call. And this request is sent to the MCP client, to the MCP server, and you get the output. Once you get the output, that output is fetched to the LLM, is given to the LLM, and then LLM format the answer in a more readable format and more better format, and it gives the output to the user. So LLM has a big role in this MCP architecture. I hope you understand this. If you have any confusion or you're not able to understand what where the LLM gets fit into this MCP, please post your answer doubt in the comment, or you can directly connect me through LinkedIn. You can directly ping me. You can directly mail me. I will surely come to your answer. I'll try to explain you in a very easy line. But I'm just trying to be. I'm not going very technical. I'm just trying to make you understand in a very easy way. But still, if you have any doubt, please post your question in the comment. We are coming to the question: why MCP will not replace RAG? So we have seen like there are multiple advantages in MCP as compared to RAG, but still MCP is not going to replace RAG. Actually, there will be a combination of MCP and RAG in multiple use case. For example, the user has a question like why the sales of particular article or particular product has gone down in this season. So in that case, the AI tool will have to gather two kind of information. The first information is what is the current sale, what was the previous sale, and try to create a graph in that and other factors regarding that. The other thing is AI also has to go into the policy or the sales document of the company's internal document to understand like what was the expected sale in this particular season and what was the historical sale. So in that case, for getting the new kind of data, like what is the recent data, what is the actual data, or what is the previous season data. So in that case, MCP will be used to connect to the external devices or external databases. So AI will use MCP. AI application will also use RAG to get the information from the company policy or sales policy document to understand that what was expected in this particular season and what was the historical forecasting for this particular season. So in this scenario, in multiple kind of this scenario, for example, like a data engineer is asking a question to AI application, like what are the different or what were which all job has failed for particular application and why it has failed. So which job has failed? In that case, MCP will be used to get the job status and which job has failed. The second thing is what is the root cause of that job failure. That also can be get we can get from the MCP with the help of log. But to give a more relevant information, RAG will be used to collect the historical data and understand what like have is that is this particular issue has occurred previously. If it was occurred, what was the solution at that time. So this kind of information, if you want to provide in this kind of prompt or questions, in that case, RAG will be used. And in the modern architecture, we are going to see how the GenAI pipeline modern architecture is going on in multiple organizations. In that, you will see that client are using MCP plus RAG together in their own in the full GenAI pipeline architecture. We'll look into it now. So the modern AI architecture is LLM plus RAG plus MCP. So, for example, there is a question: why did sales drop yesterday? So, this question is asked: why did sales drop yesterday? So, LLM or this is LLM actually, LLM or the AI agent layer. This is the decision-making brain of the system. Okay, so like as we have seen, like LLM decide which tool to use from the MCP server. So, this is actually the decision-making making area. It understands the question, decide what information is needed, and decide whether to use RAG or MCP tool. So user has asked about, so it understands the intent that user has asked about the sales drop. So user needs sales data plus explanation. Now there's a decision layer where agentic logic comes. The AI agent determines which path to take. If the question needs knowledge, then RAG is required. If the question needs system data, then MCP is required. Example, sales numbers can be retrieved from with the help of MCP. Pricing policy explanation can be retrieved from the RAG. And for this, it's like you can directly create all this manually with the program, but you need a framework for that so that that context or the information gets get passed into the parameter, and it will be very easy. Not easy. It will be good if you do the development in this way by using some framework. For example, Lang chain, Lang graph. So if you have multiple actions to perform, you can go with the Lang graph. If you have a simple actions, one by one to one action sequence wise, you can go to the Lang chain. There's a crew AI. You can also use if you're using working in a GCP. Apart from GCP, can be also used in Google ADK, but it is also tightly with the GCP services, Google ADK, or you can use Vector DB not Vector DB. Sorry, you can use the Vertex AI for this. So first, this AI agent layer understand what is the intent. There is a decision layer. Agentic logic understand which tool to use or which path to takes. So in the enterprise system layer, like now it decided where to go. So there's an MCP server, and MCP connect to multiple things to get all this information. So like for example, you want to get the current sales data. So it will connect to the database, API, some file system. So there is an analytical platform. These can be used as an MCP server inside the MCP server. An example for the tool can be, or the external source will be Snowflake, Airflow, Databricks. So you can use MCP server of the Snowflake itself also. So I mean to say that these are the things in which MCP will help you to connect with. After retrieving or executing the tool, means if after using the RAG or using the what do you call MCP thing, means executing the tool, or if you're using RAG plus MCP both, these both information, then LLM combines everything and produce a final answer. The answer, for example, sales dropped yesterday because inventory ran out in the north region at 3 p.m. So north region at 3 p.m. will be retrieved from MCP, but inventory information or has got information dropped, for example from the inventory data, like what was the previous inventory and got dropped, so that information can be retrieved from the RAG. So this, like this answer what you see here can be the combination of multiple input to the LLM, and that input LLM will get from the RAG and from the MCP. Yes, sir. Now you can see the architecture of this. The user has asked the question. The application can be Copilot, it can be a cloud desktop, anything which you can use MCP. And then LLM or the AI agent does the decision layer. It makes the decision, like you want to go to RAG or MCP. RAG in case of knowledge retrieval, MCP in case of tool access, system calls, and it connects to the enterprise system. For example, it connects to the Snowflake, file system, or any of the external tool or system. Answer is get into the LLM generated response. Like LLM gets all this input, LLM generates the answer and gives to the user. So this is the most effective and most useful GenAI data pipeline currently being used. So if you have not learned RAG, If you don't know about the RAG application, I'll just come up with a video of creating it. You will get it multiple videos in the YouTube. Try to create some RAG POC, do some POC on the RAG, because MCP is not going to replace RAG. You can see that this architecture is going to run for a longer period. So understand RAG, have full control on MCP. LLM, you have the model. Try to combine this, use any of the framework, LangChain or LangGraph. I'll just suggest go with the LangGraph, open source, and then create do one POC and create one full GenAI pipeline with using all this stuff, and then you'll be good to go with the GenAI project or GenAI client. If you have any doubt in understanding this flow, please post your question in the comment. And you want me to explain more into some of the part of this flow, that also you can post in the comment. I'll come up with the in the next video. You can connect me through LinkedIn, or you can directly mail me. My Gmail ID is in the channel description. Do subscribe to the channel and please spread this channel to your friends and colleagues. Till then, happy learning and take care.